It's time for a notorious topic. Understanding closures. Closures is a JavaScript topic that's absolutely vital to understand if you're going to advance at all in understanding and writing the language. However, it's also notoriously difficult to understand. But you're ready. At this point, I hope that you'll see that all the time we've taken to understand how things work under the hood, to understand first-class functions, to understanding the execution stack and the execution context, that all of those things right now are about to pay off in understanding closures in JavaScript. To start with, we're going to write a bit of code that will show the power of closures, and then we'll examine it under the hood to understand what's really going on. I'm going to go ahead and create my good old greet function, but this time I'm going to accept a parameter of what greeting I want to say, maybe hi or hello or howdy or hola or whatever. And instead of doing the work inside this function, I'm going to return a function using a function expression. And I'm going to take advantage of the scope chain, to include what to say, space, and then a name. Take a good look at this. I have a function that returns a function. So when I call greet, when I invoke it, I'll get a value back. But instead of a string or a number or something like that, I'm going to get a function that I can then invoke again. Make sense? Because functions are objects, I can just return it as a value. That makes for some interesting syntax. Like, for example, I could say greet. I want to say hi. Now this returns a function. So how do I invoke the function? I invoke it and say Tony. Looks a little weird, right? But you're invoking a function that returns a function, so then I can invoke the function that was returned. So if I run this and open up my console, hi Tony. All right, so that makes sense. And yet, something unusual is already happening. To understand just how unusual it is, to make it a bit clearer, let's do this a bit differently. Let's set a variable equal to the result of the function. So now say hi will be a function, the function that was returned by calling greet. Then I call say hi. And if I run this, it still works. But let's stop and think about this for a minute. How does the say hi function still know the what to say variable? Because the what to say variable was created here when this greet function was called. And then that function is done. It's over. It completed its execution. It's popped off the execution stack. And yet, when I call say hi, when I invoke it, it still has the proper value of what to say. See that? How is that possible? It's possible because of closures. Let's take a look at what's happening under the hood when this code is executed. I have my code, and remember this seems unusual because the greet function ends, and when I invoke the function that is returned, it seems like that greet function is still hanging around somehow because the what to say variable is still there. So what's happening? Well, when this code starts, we have our global execution context. When I hit this line, say hi equals greet, it invokes the greet function, and a new execution context is created. And that variable that's passed to it, what to say, is sitting in its variable environment. It returns a new function object. It creates a function on the fly and returns it. And that's it. So after that return, the greet execution context is popped off the stack. It's gone. But here's a question. We said every execution context has this space in memory where the variables and functions created inside of it live. What happens to that memory space when the execution context goes away? Well, under normal circumstances, the JavaScript engine would eventually clear it out with a process called garbage collection. But at the moment that execution context finishes, that memory space is still there. It's still hanging around. The execution context may be gone, but it's just sitting there somewhere in memory. All right, now we move on and we're inside the global execution context again. And then we invoke the function that sayHi is pointing at. It's an anonymous function because we didn't give our function a name when we returned it. And then that creates a new execution context. And I've passed the name variable Tony, so that will end up in its memory. But when I hit this line, console.log, when its code is invoked, and the JavaScript engine sees the what to say variable, what does the JavaScript engine do? Well, it goes up the scope chain. We've learned this. There's an outer lexical environment reference. In other words, it goes to the next point outside where the function was created to look for that variable, since it couldn't find it inside the function itself. And even though the execution context of that function greet is gone, was popped off the stack, the sayHi execution context, this execution context, still has a reference to the variables, to the memory space of its outer environment. In other words, even though the greet function ended, it finished, any functions created inside of it, when they are called, will still have a reference to that greet function's memory, to what was in its memory, its execution context memory space. Think about this for a second. Greet is gone. The execution context is gone, but what's in memory for that execution context isn't. And the JavaScript engine makes sure that my function can still go down the scope chain and find it, even though it's not even on the execution stack anymore. In this way, we say that the execution context has closed in its outer variables, the variables that it would normally have reference to anyway, even though those execution contexts are gone. And so this phenomenon of it closing in all the variables that it's supposed to have access to is called a closure. Make sense? It isn't something then that you create, that you type, that you tell the JavaScript engine to do. Closures are simply a feature of the JavaScript programming language. They just happen. It doesn't matter when we invoke a function. We don't have to worry if its outer environments are still running. The JavaScript engine will always make sure that whatever function I'm running, that it will have access to the variables that it's supposed to have access to, that its scope is intact. Make sense? This is a feature of the language that's extraordinarily important and powerful. We rely on it a lot. It allows us to make some really interesting coding patterns. And understanding what's happening under the hood helps us to understand closures aren't all that complicated. They're just a feature to make sure that when you run a function, it works the way it's supposed to, that it has access to those outer variables. It doesn't matter whether the outer functions have finished running or not. So when you say, oh, I create a closure, well, sort of. You'll read that sometimes. I create a closure. The JavaScript engine creates the closure. We're just taking advantage of it. All right, so let's look at what may be the classic example of how closures can end up in surprising results when you look at code. But if you understand what's happening under the hood, it may not be so surprising after all.